class. This is Miss Martins, and we are in Unit 7 Solutions. Before we get on to today's topic, I would like us to review an initial activity question. So the question reads, in a liter of human blood, there are 9 grams of salt. What is the NaCl salt molarity of human blood? Right? So because this question asks for molarity, we're going to go to table T and look at the molarity equation. The equation reads, molarity equals moles of solute over liters of solution. So within this question, we are given the liters of solution, where it says in a liter, so that means we have 1 liter. However, we're not given the moles in order to determine the molarity, but we are given the grams. So in order to go from grams to moles, we're going to use this equation. Number of moles equals given mass over gram formula mass. This equation is also found on table T, which is on the back of your reference table. So we're given 9 grams of salt, so we could place that as given mass, and we have to determine the gram formula mass. Because we were given the chemical formula, determining the gram formula mass is not an issue. So looking at our reference table, we can determine that the atomic mass of sodium is 23 AMU, and the atomic mass of chlorine is 35 AMU approximately. So 23 plus 35 is going to give us 58. We're going to plug this into our moles equation. So 9 grams over 58 grams per mole is going to give us 0.155 moles of salt, right? And in order to determine the molarity of salt, we're going to plug our moles into our molarity equation. So 0.155 over 1 liter of solution is going to give us 0.155 molar of salt in human blood, right? This is very essential in understanding our objective for today, which reads, students will be able to gather information on a titration procedure by defining key vocabulary, tools, and using the titration formula via an exemplar to prepare for a successful lab. And you guys are probably asking, what does titration even mean? How do I even do titration? And that is what today's lesson will be about. So titration is a controlled acid-base neutralization reaction. If you recall, a neutralization reaction starts with an acid and a base, and it produces a salt and water. Remember, a salt is an ionic compound, which consists of a metal and a nonmetal. Titration is also a procedure for determining the concentration or molarity, hence why we reviewed a molarity question of a solution. So, in order to understand what titration is, we're just going to go through this problem. Let's say we are starting with an acidic solution, which is going to be in this Erlenmeyer flask, HCl, and we know the volume of it. So let's say there's 20 milliliters of HCl in here, but we do not know the concentration. We can find out the concentration by doing a titration reaction or experiment. So next we need to add a few drops of an acid-base indicator. If you can remember, an indicator can tell us the pH of a specific acid or base. So adding to the acid flask, we're going to add a few drops of indicator. And in this case, we're going to add phenolphthalein. I apologize if I'm not pronouncing that correctly. So phenolphthalein is colorless in acid, but it turns bright pink in a base. So our base is going to be in this burette, and we're going to keep adding small amounts until it turns a light pink. If it turns too pink, that means we have gone too far and we've added too much base. So a tiny excess of base means we've neutralized all of the acid present. So once we get a light pink, we know that our acid has been neutralized. And this is what we're going to call the end point of a titration. And here we stop and we check our volume of our base that we used in our titration. So we have a beginning volume, and as we add the base, the volume of the base is going to deplete, and that end volume is going to help us in determining the initial concentration of our acid. So a few vocabulary words that I would like you guys to review in order to become an exemplar with this topic is titration, which is an experimental procedure in which the concentration of an unknown is found using a known. Indicator dye is a dye that changes from clear to pink in color depending on whether the solution is acidic or basic. So remember, in our example, when our solution is clear, that means it's acidic, and we're going to add our indicator dye to that acidic solution. It will remain clear, and once our reaction has become neutralized, our solution to turn a light pink. If it's too bright, that means that it's more on the basic side and our solution isn't really neutral. The end point is a color change in which marks the end of titration. So once we get that initial slight pink color in our titration experiment, that is referred to as the endpoint. Reading the burette is very essential for doing titration experiments. We're going to assume that the burette is filled to the point indicated in the figure at the left. So here is our burette here. And for burettes, we're going to read top down. The higher numbers will be on the bottom. The lower numbers will be on the top. So for our initial reading, we're going to get 3.0. This is 3.1, 3.2, 3.3. You're going to read at the bottom of the meniscus. And we're going to keep pouring in our base into our Erlenmeyer flask. And here, our number has gone from 3.3, which is here, to 3.4, 5, 6, 7, 8, 9. 3.9 at the bottom of the meniscus is going to be our final volume. Therefore, that titration would have required 0.6 milliliters in order to occur, and this number is what we're going to use in order to figure out our initial concentration for our acid. Remember that you should read the number that is at the bottom of the meniscus. So where the curve is the lowest, that is the meniscus, and that's where you're going to read your volume on your burette. So let's try an example together. A burette is filled with 0.7 molar NaOH, which is going to be our base. 20 milliliters of HCl is going to be in the Erlenmeyer flask, and it has an unknown concentration, which we're trying to figure out, which is why we're doing the titration experiment to begin with. A few drops of phenolphthalein is going to be added to our acid, this 20 milliliters of HCl, and the titration procedure is started. So we're going to keep pouring in our NaOH into the Erlenmeyer flask, and before we pour it in, what is our initial volume of the titrant, the NaOH? So this is how you read a burette. So this is 15 here. This is going to be 15.1, 15.2, 15.3, 15.4, 15.5, 15.6, 15.7, 15.8, and the meniscus is a little below 15.8, so I'm just going to roughly approximate that to be about 15.82. With burettes, we want to read to 2 decimal points, right? And then the base is added until the solution is a pale pink. Based on the image, what is the final volume of the base? So I'm going to start from here, 27.1, 2, 3, 4, 5, 6, 7. This is about 27.7, and it's far below that, so I'm going to say that is 27.76. So our initial volume was 15.82. Our final volume was 27.76. I'm going to subtract those numbers, and I'm going to get a volume of 11.34, and the units is milliliters for a burette. So in order to find the concentration of our initial acid, we're going to use the titration formula, which can also be found on table T. A burette is filled with 0.7 molar of NaOH and 20 milliliters of HCl of unknown concentration is added to an Erlenmeyer flask. Then VA is going to be the 0.2 20 milliliters. That's how much, no, 20 milliliters is not 0.20, it's 20. So 20 milliliters is our volume of our acid. That is known. Then we have our molarity of our NaOH, which is going to be 0.7. Our volume of the burette, that the displaced volume of our NaOH, we found to be 11.34, right? So this is how we plug in our formula. We have X times 20 milliliters is equal to 0.70 times 11.34. 0.7 times 11.34 is going to give us 7.93. And then we're going to divide our 7.9 by 20. And we get our initial volume of our acid to be 0.4 molar. For our next and last example, it reads, this is also one of the homework problems that you guys will be doing. Determine the concentration of 15 mLs of an unknown acid based on the following titration data. 30 milliliters of 0.3 molar NaOH is used to bring the titration to its endpoint. So our equation, which is found on table T, once again, the last page of your periodic table, reads the molarity of the acid of H plus times the volume of the acid equals the molarity of the base times the volume of the base. So the molarity of the acid is what we're looking for. We know the initial concentration of the acid, which is going to be 15 ml. The volume of the molarity of the base is known, and they already brought the titration to an endpoint, and it said it took 30 milliliters for the solution to turn pink. So we're going to multiply 0.3 times 30, and that gives us 9. And then we're going to divide 9 by 15, and our answer is 0.6 molar. This is our second and our last example. If you're having any difficulty understanding this topic, please watch this video as many times as you need. I will also be live for about an hour today, and I have a bunch of practice problems that you can practice with. I will be posting the answers on Google Classroom later in the day. I hope you all are doing well. Enjoy your day, and thank you for listening to this lesson.